topic 1.7, rational functions and end behavior. So a rational function is simply the quotient or fraction of two what? Two polynomials, perfect. You can say polynomials or functions. You can also say the word functions. So, for example, function here, and they're both polynomials, and you can't ever divide by 0, so it made this extra note, don't accidentally divide by 0. So far, so good. You just have some division going on. These are some rational functions. There they are. Oh, wow, look at that. It's a polynomial over a polynomial, polynomial over a polynomial. We're going to be analyzing what happens in specific cases. So there's going to be 3 cases that will happen. We only want to look at the leading term of the numerator and the leading term for the denominator. And when I say leading term here, what we can really say here is the biggest. This should be in standard form, so it should be the biggest power. So if I have a bunch of other stuff, like for example up here, I see all this minus 3x plus 1. What I would do here is I would get rid of all this stuff. I only want to look at the biggest power. I'd look at the denominator and say, oh, plus 4, get rid of it. It's kind of nice for this topic because you ignore a ton. You only look at that first value. You look at the first value. There's going to be 3 things that will happen. The first thing that can happen is that they have the same degree. So what would be an example of that? Down here, you can check it out. 2 and 2 are the same degree. If the powers are the same, that means we take their coefficients, and this is what's known in my class as the magic fraction. So when we have the same over the same, it's a magic fraction. So same degree, magic fraction. What happens if the denominator is bigger? So this is saying I have something that's on the top, that's nice and small, something on the bottom that's nice and big. If the bottom is bigger, the answer here is that the horizontal asymptote is 0. So this turns into 0. And again, using these words, the horizontal asymptote, the horizontal asymptote. What does horizontal asymptote mean again? An asymptote is kind of like this magnetic force that pulls you closer and closer and closer to it without ever touching it. Asterisk. Sometimes it does touch once, but then it gets closer and closer and never actually touches. I think I'll show you an example on the back. This is a horizontal asymptote. First of all, this is the horizontal direction. This is the vertical direction. We have this horizontal asymptote, and you can see as I pull my function out to the right, out to the right, out to the right, it's getting closer and closer to the asymptote. As I go out to the left, this function is being pulled down and down and down, closer and closer to this asymptote, but it never actually touches. Think of it as the electric fence. If you touch it, you get shocked. All right. We're trying to figure out where that electric fence is. Where is that asymptote? The asymptote can be a value, it can be a fraction, it can be 0, or it has end behavior. So what happens if you have the top bigger and the bottom smaller? If the top is bigger, if the numerator dominates the denominator, and this is purely in terms of degree or the power that x is being raised to, then you just do whatever end behavior you have. Sometimes it shoots to positive infinity, sometimes it shoots to negative infinity. You have to decide which one. It's either plus or minus infinity. We don't know if it's going up versus down, but it goes off the charts. It either goes off the charts that way or that way. And then this is kind of a cool thing that I haven't really taught that much before, but it's nice to know this. Whenever your numerator is exactly 1 degree bigger, so exactly 1 degree bigger would look like something like this. Everyone take a peek and see. This is a power of 2, this is a power of 1. 2 is exactly 1 bigger than 1. The numerator beats the denominator by 1. Whenever that happens, you get something that has a slant asymptote. Instead of having a horizontal asymptote, the asymptote goes like that. I'll show you more about that on the back, but I'm saying that now. All right, so on the front, we're going to say either horizontal asymptote, and at what value, slant asymptote, or neither. Ready, set. All right, all we're doing is we're comparing the highest degree. So on number 1, part A, yep, you already seen it, Claire. Cross out everything. You say, oh, look, this 2 and that 2, we have the same. So if they're the same degree, what do we do? What do we do with same degree? Magic fraction. Magic fraction, you take the numbers out front. They take the numbers out front, and that's the fraction. Magic degree implies magic fraction. I don't have to write this every problem, but this is just for our notes. This is a magic fraction, and therefore the answer is 3/5. What this means is if I were to draw out, you don't need to do this, but if I were to draw out a graph and I come up here to this height of 3/5, I would have this electric fence here at 3/5 where the function is being pulled closer and closer to this asymptote without actually touching it. That's the height of 3/5. That's where our horizontal asymptote lives. All right, on B, what do we have?
0.
This is going to be a horizontal asymptote of 0. So we'll say horizontal.
Isn't the top?
The horizontal, do you guys know how to pronounce this word? Who thinks that they can do it for the class? Asymptote. Again, P is silent.
What was asymptote? Like A-S-E-N-T-O.
No, asymptote. No, it's asym. Well, you pronounce the M like an M, not an N. So it's asymptote. And the horizontal asymptote is at what height? It's at the height of 0. At 0. Why? Because this one was a tiny top and a very big bottom, where this was a power of 1 over a power of 2. These are what I call my top-bottom rules. Maybe I should label that too. Really, these are going to be labeled the top-bottom rules. All right. What about in D? What's going on? Someone other than Claire. She's been doing the heavy lifting. What's going on with the degree? It's not 0 again. It's not infinity. It's a magic fraction. Why is it a magic fraction? Same power, same power. So if it's the same degree, that means that we're doing a magic fraction. Oh, did I skip C? Sorry. My bad. What's the magic fraction going to be?
I just thought we skipped it because we already kind of looked at it.
I should have looked at it a little bit more. But let's do D and then we'll go back to C. What's the fraction for D? 4/8, which reduces to 1/2. So this is the horizontal asymptote. Part D has a horizontal asymptote at the height of 1/2, and it is indeed a horizontal asymptote as opposed to a slant asymptote. Sorry, let's go back to part C now. What is this one going to be? Go for it, Josue. This one is it going to be positive or negative infinity?
How do you know that?
You check to see the sign. You look at this, it's a positive over a positive, therefore it's going to shoot out to a positive.
Is negative or positive? It's negative. Negative is positive? Or no, negative.
Well, you have to be careful. It depends on what happens when I go to the right or the left, doesn't it? So let's go ahead and say when I go to the right, what happens, and when I go to the left, what happens? When I go to the right, I shoot out to positive infinity because these are positives. What happens when I go out to a really big negative number? Again, you can kind of subtract these powers. 2 and 1 makes this 1, which is an odd number. Odd numbers match or mismatch? Mismatch, therefore negative infinity. Good. What else do you notice about C for my extra note here? What was I talking about in that extra note?
It's slanted.
It is a slant. Why?
Because it's 1 degree over.
Slant.
Wait, do we have to write the right and left every time?
This is extra
Okay.
that we would like to know. It's a slant asymptote. Why? Because top is the bottom plus 1. If I take the top degree, I'm just adding 1 to the bottom degree, therefore it's a slant asymptote. So there's our final answer, slant asymptote. Part D, we already did. Part E, what do we got? Go for it, Saul.
Part
E.
Well, so. What are you laughing about? So, Anthony obviously wants to do it.
No, it's just
He was
my
laughing.
notes, like, yeah.
Good to know. Saul, come on.
Okay, so you cross this one out, and that one out.
Okay.
Yep. And then you have 3 over 1.
3 over 1. I mean, 3 over 1x squared, I guess, yeah?
And then so, but what you have here is a horizontal asymptote of 0.
Yes, why?
Because the top is bigger than the bottom.
I think you said that backwards.
Yeah.
Yeah, I brought it bigger than the top side because there's 0 at the top.
Yeah, this is technically x to the power of 0. This power and this power, when I compare them, I have the top nice and small, the bottom is nice and big. Therefore, horizontal asymptote at 0. Perfect. And last but not least, Anatoly really wants to do this one.
So, like,
Oh, I didn't see that.
this is gonna be horizontal asymptote.
It is.
There's no power on top. There's to the power of 1 on the bottom.
It's essentially 4x to the power of 0, so it's the top is nice and small, the bottom is nice and big. As horizontal asymptote at,
That one's also slant. No, it's not. It's the bigger. If the top's bigger.
if the top is bigger, it can be slant, yeah. Where's the horizontal asymptote, Anatoly?
3. 4.
Nope.
Let's see.
Where's the
what?
Wait, what? Horizontal asymptote.
You said it correct. It does have a horizontal asymptote. Where?
That's it.
No.
0.
I don't know.
0. Why 0, Claire?
Because it's the second one.
It's the second one. Whenever you have the bottom bigger than the top, the answer is always going to be 0.
Nice.
Okay, well, you're learning. That's what the notes are for. All right. Let's do another one. This time we have to actually look at the left and right behavior, which is what I wanted to do earlier, but I got too hasty. All right. Let's give this one to Josue. First of all, what do you notice about the top-bottom rules?
They're the same.
They're the same. Therefore, this one is going to be a magic fraction.
2 over 6, right?
It is going to be the fraction 2 over 6, which is the same as 1 over 3. So that is the left and it is the right. So let's practice saying this. On the left, the way that we say that is the limit as x approaches what? Negative infinity of our function, in this case f of x, and that's equal to that height, 1/3. Claire, how do I say the other notation? How do I say the right behavior? I want to write this, but now for right.
X, arrow, infinity, f of x equals whatever it equals.
No.
What does it equal? What height am I approaching?
Yep, that one.
1/3. Magic fractions are interesting because it is the left and it is the right, no matter what. All right. Anatoly's up for this one.
That's a lot.
I got it.
Anatoly, what do you notice about the top-bottom rules?
So the bottom is bigger, so it's horizontal asymptote.
It is?
Yep.
Where? On the left, it's what? On the right, it's what?
Both 0?
They're both 0 because the bottom is bigger, therefore it's 0. So how do I write out the limit notation?
So lim as x approaches negative infinity is going to be
Of g of x
oh, g of x equals 0, sorry.
equals 0. And then what about the other one?
Lim as x approaches negative infinity, I'm talking positive infinity, g of x equals 0.
Done. And Saul gets the last one.
Hell no.
Well, C, I should say. We have D and E still to go.
Okay, so left lim when x equals is going to negative infinity. g of x equals h of x equals 0.
Not 0 this time. Use your top-bottom rules. What do you notice about the top and the bottom for the degrees?
They are different.
They are different, yeah. They're not the same, so it's not a magic fraction. This one was different too, although the bottom one. Who wins this one?
Top.
So the top is big, so top in all caps. The bottom is tiny. What does that mean?
It means that it is a slanting.
A slant asymptote. Exactly. It is a slant asymptote, but that does help us, but it doesn't give us the answer, where am I going? I'm either going to positive or negative infinity because I have a top, that one. It's one of those two.
You're going up.
Why are we going up?
Because you're going down.
Why are we going down?
Because Anatoly said so.
I mean, he's right, but why is he right?
Because it's Anatoly.
Yeah, because I'm Russian. No, it's because we have a negative up top and a positive down, so it's negative. It's negative, so it goes down. So negative.
Yeah, like what else?
And then
Negative sign up top.
So watch this. We typically always start on the right, and here's why. Saul, when I subtract these two, because you always do subtraction when I do division, subtract the powers when I divide like bases. So this is really a negative 3x to the power of 1, essentially, is what I've boiled this problem down into.
Yeah, so that means it's going to go right's going to be positive, left's going to be negative.
So the right side will always take the sign
Oh,
of that negative.
so the opposite.
It's the opposite. The right side will be negative infinity. Repeat that back to me, Saul. Why is the right side negative?
Because there's a negative.
Exactly. The left side. What do we know about the left side? The left side all depends on this power or degree.
So if it's odd, it's negative.
If it's odd, it's not negative. If it's odd,
It stays the
it's
same.
opposite.
it changes. If it's odd, it changes. So this one is a positive infinity. Good. All right, on to Claire. This one is just a graph. So go ahead and practice writing the limit notation. How do I write the left limit?
X, arrow, negative, infinity. Is it?
Let's just call this thing f of x. I don't know what to call it. F of x is equal to what? What height do I seem to be getting closer and closer to? 2. Done. How do I do the right limit?
Lim, arrow, positive, f of x equals 2.
As I go to the right, I'm also approaching this height of 2. Again, it's kind of this magnetic electric fence. You get closer and closer, but don't touch it. You get shocked. Josue, E, finishes off. We'll call it f of x.
I'm still confused on why sometimes it's just lim of negative, x equals negative, and then sometimes it's the bottom one's 2 infinity, and sometimes it's not.
Like this part right here.
Yeah.
Negative always means left.
Yeah.
Positive always means right. 100% of the time whenever you have limit notation.
No, up on C, it says lim x equals negative infinity. That's why you messed up.
He's talking about.
Left will always be negative. Right will always be positive.
Now I see it.
Okay. What is this one, Josue? -1. Again, we have this electric fence right here that is a horizontal asymptote. Horizontal asymptotes are synonymous with top-bottom rules. They are one and the same. And the limit... What's up?
What's right going to be then?
As x approaches positive infinity of f of x will be what, Josue? -1, yeah.
What about all those lines? Yeah, what are vertical lines and stuff?
Vertical lines we will talk about at another time, but vertical lines will either be a vertical asymptote as opposed to a horizontal asymptote. You could also get weird things like removable discontinuities, and you can have zeros. Those are the top pieces. What we're dealing with are the bottom pieces, I guess. All right, and then finally, slant asymptotes. I told you I'd be going over it later. Now is that time. I'm just reading to you guys. You guys are paying attention and not talking to each other. Slant asymptotes. If the degree of the numerator is exactly 1 greater than the degree of the denominator, a rational function will have a slant asymptote that is parallel to the ratio of the leading terms. It's kind of like a magic fraction, except instead of a magic fraction that the answer is like that, it's a magic fraction where the answer is like that. It'll be a line that goes up diagonally, still using those coefficients. So we're looking for following functions that are parallel to 1/2 x. Notice that 1/2 x is not a constant. It's not this flat line. 1/2 x is this line that looks like this. It's no longer flat. We're looking something that is parallel to this line.
Oh, a slant.
A slant asymptote. So it's a slant electric fence. Someone installed the electric fence wonky. It's falling apart. So first of all, we need to make sure that the numerator's power is exactly 1 higher than the denominator. Does that apply to 1? You guys can all shout out. No. These are exactly the same power and same power. What about in part 2? No. I need to have the top 1 bigger, not the bottom 1 bigger. What about 3? 3 is good so far. We can't eliminate it. And what about 4? 4 needs to be 1 higher than 2.
No.
So it's not 4. So it's just 3. So the correct answer here is only 3. But did we get the number right? Where did 1/2 come from? Can someone explain where this 1/2 came from?
Right there.
Yeah, that's
It's right here, but tell me, where do you see 1/2 in this box?
so in number or in the box number.
Where does 1/2 come from? You have to get the right numbers too.
It's
1/2?
the x.
See, like free x you divided by
It's
2 is
the
gonna
x is
or no,
1,
it's not.
x
No,
to the 3,
no, no.
and then there's 2.
3x times 2 is 6.
The coefficient, as Claire said, of the x squared term is 1. The coefficient of the x term is 2. If I only look at the coefficients like I used to with the magic fraction, I get 1 over 2, or the fraction 1/2. And that is a slant height just based on the coefficients as long as this power was 1 bigger.
Are we going to have to look at that in the future because it's going to get complicated?
Will we have to look at that? What do you mean?
Well, we're learning
Because,
it
like,
from
what if the last one, number 4,
Yeah.
was 3, 2? I guess that would be the same.
If this one was a 3?
And also, yeah. because
Yeah,
it would
then
also
it'd be-
1 over 2.
Exactly. That would also be
Are we
a
gonna
slant.
have to look at that because it would get complicated?
What do you mean?
Or
Will
what
we?
if the bottom was 3?
If the bottom was
And they gave
3,
you 1 over 2.
then it would be, yeah, both of those answers. You will have to, you always look at them, yeah.
Okay.
All right, we are switching to the worksheet now.
No.
Already? Should we do it together?
We should do it together.
Cool.